Bismillah ar-Rahman ar-Rahim. Let's look at this OCW. I think this is the first one in the couple moment. I'll give you the number after I solve it. So if the resultant couple of the three couple acting on the triangle block is to be 0, which means that all the moments, all combined, we have here one couple moment, this force that will produce a couple moment. That's couple moment number 1. And we have this force that will produce couple moment number 2. And this force that will produce a couple moment number 3. So we have 3 couple moments acting on the triangle block. The resultant of all these moments added together. So MC1 couple moment plus the couple moment of 2 plus the couple moment of 3 is equal to 0. Determine the magnitude of force F and force P. So he wants to find out the force F and the force P. Okay, tension T is given 540 Newton, and the distance dx, let's put it in millimeters, 730 millimeter. Let's start doing the first moment. Let's say the force F. The force F, which is MC1. For MC1, first of all, we need to find out the force F. You can see that this force is going in the positive Z. Okay, so this is equal to F in the positive Z, so I'm going to keep it like that. Now, for the determinant, I need to find out the position vector. Now, since this is going in the positive Z, so I'll take this. And I will go from the point, let me just do it in red, from the other force, which is the other force opposite in direction, toward the force that I'm going to take the calculation at. So I'm going to take RCB for this one. So I'm going to make the position vector RCB for the force F that will produce a couple moment, and that's of course going to be clockwise. Okay, so the RCB is going to be determined by finding, first of all, what is C? What is the coordinate C? The coordinate C, you could see it. It is coordinate C here. It is at the Z-axis, nothing in the X, nothing in the Y, and there is 0.3. I'm going to call it 0.3 meters because 300 millimeter by 1,000, it is 0.3 meters. Okay, that is C. Now B, you can see B here, it has an extra X, which is 730. So that's going to be 0.73. And also 0.73, and also the Y is 0, there is no Y, and there is an extra Z going up, 0.3. So if you want to find RCB, then B minus C, 0.73, I, this is in Newton, 0.73 I, 0 minus 0, 0.3 minus 0. Okay, so this is in meter. So we found now we could find out the moment or the couple moment of the first force, F. So if you want to, let's call this one MC1, I, J, K. We put the position vector, this is I, 0.73. There's nothing in the J, nothing in the K. And we put the force down. So 0, 0, F. So let's see what we're gonna do with the first one. If we do the I, 0 minus 0. Okay, so this is 0. So we have to, don't do it. There's 0 here. Let's do the minus j. Minus j. Okay, 0.73 times f. 0.73 times f. Let's do that. Let's do the last one. The k. Okay, it's 0. So this is it. So this is for the first one. This is the couple moment number 1, MC1 is equal minus 0.73 Fg. And that is, of course, in Newton meter. Let's go for the next force. The next force, let me take B. I'll take this positive B. So the next force, P, which is the magnitude P, and this is in the Y, so this is in the J. What is the position vector that I'm going to take this couple moment at? Okay, I'm going to go from the other, let's say, from this point, that were the other force opposite in direction, toward the force that I took, or I'll take the calculation at. So I'm going to go AD. So I'm going to do RAD. So because I took this force, so I'm going to take the position vector toward that force that I'm going to take my analysis at. RAD, we don't have A, we don't have D, so let's do, what is the coordinate of A? Let me just clean up this. Coordinate A and the X, it's 0.73. And the Y, this is A, 0.4. And the Z is 0, because it's in the floor. D is in the Y, so it is 0. The Y is 0.4, 0. Nothing in the Z. So now RAD, D minus A, 0 minus 0.73. Minus 0.73 I. 0.4 minus 0.4, 0 minus 0. Okay, so it's all gone. This is in meter. So now we could find the couple moment. Let's call this one MC2. I, J, K. We're going to put the position vector here, minus 0.73 I, 0, 0, and 0, P, 0. Okay, this is equal to, let's do the first one. The first one, the I, 0 minus 0, so there's nothing in the I. Let's do the minus J, 0, 0, so there's no J. Let's do the K. Okay, so the K, it is minus 0.73 pk. Okay, minus 0.73 pk. Okay, and that is for the second force. Let's look at the second force that will produce a couple moment, which is the T. So now the T, what's the direction of the T? The T, you can see it, I'll take this T. This is in the positive I, so this is T in the positive I, and that is Newton. And also the position vector. I'm going to take it, since it's going to be, I'm going to use this force. So, and this is the other force. I'm going to go from A, from the line of the action of the opposite force, toward the line of the action of this force. So I'm going to go toward this force. So I'm going to take AD. A AB, sorry, AB. AB. So I'm going to do RAB. Do we have A? Yes. Do we have B? Yes. So RAB, which means B minus A. B minus A, 0.73 minus 0.73, 0 minus 0.4. AB. Okay, and 0.3K. Okay, so now we do the moment, the last couple moment. Okay, I, J, K, and now I'm gonna put the position factor here, 0 minus 0.4, 0.3, this is 0.4, and I'm gonna put, this is TJ, no, this is TI, this is TI. Tension is T in the x-axis. Okay, so I'm gonna put the tension here in the I, 0, 0, and then I'm gonna do the I, nothing, 0, 0. I'm gonna put minus J, up, J. This is minus 0.4. I'm gonna do the J, 0, okay, so minus J minus 0.3T, minus is a plus, and I'm going to do the last one, the K, zero minus, and that is 0.4T. And that would give you 0.3 TJ plus 0.4 TK, and that is all in Newton. That is in Newton meter. That is also in Newton meter. Okay, so the force would be in the Newton. So you should make sure that you have all units. Okay, so now we're gonna add up all the couple moments. The first couple moment is this one, minus 0.73 F in the J, plus the second couple moment, minus 0.73 P in the K, plus the last couple moment, 0.3 T J plus 0.4 T K, and the whole thing is equal to 0. Now we have to add the J's together, so we'll do it like this, minus 0.73 F, this is magnitude, minus 0.73 F plus 0.3 T is equal to 0. Two unknowns, and this is one equation. Let's just do the other one. Minus 0.73 P. Okay, this one. Plus 0.4 T equal to 0. So minus 0.73 F plus 0.3 T, okay, minus 0.73 P plus 0.4 T. Okay, and he gave you the T, 540 Newton, so you could find the force. So 0.73 F, if you take the other side, is equal 0.3 T, and you have the T 540. So let's do 540 times 0.3 divided by 0.73, and that's the force will be equal to 222, and that is in 3 significant figures, 222, and that is almost true. You could just put here 222, and then the other equation, which is you do it 0.73 the other side, P equal 0.4 T, and T is given as same thing, it's 0.4540, 540 there 0.4 divided by 0.73, and that would give you a force P 296, 295.8, 296 Newton. And that is correct, 296. This is the first OCW of the couple moment, and I'll try to do the rest in the next few videos. Thank you.